Hello, this is test wrapper number 2. I chose to do problem number 4. And the problem statement is that you put a thin metal pot containing 2 kilograms of room temperature 12 degrees Celsius water on a hot electric stove. You also stir the water vigorously with an electric beater, which does 100 joules of work on the water every second. You observe that after 15 minutes the water reaches a temperature of 100 degrees Celsius. The specific heat capacity of water is 4.2 joules over grams times Celsius. And so I started this problem off by finding my knowns. My first knowns were that the 2 kilogram of 12 degrees Celsius water is in a metal pot, and then that is stirred vigorously with an electric beater for 100 joules of work per second. Then after that, I found the observations after 15 minutes reaches a temperature of 100 degrees Celsius, the water does. And then that the specific heat capacity of water is 4.2 joules grams over Celsius. And so the first question is, what was the change in delta E thermal in the water? And so you can use the formula delta E thermal equals MC delta T. Then, because we already have the numbers for that, all we do is plug in our mass, which we have to convert from kilograms to grams. So that's 2,000 grams times 4.2 times 88, which is the final temperature, so 100 degrees minus 12 degrees. And that gives us 739,200 joules for delta E thermal. We then have to find the what was the thermal transfer of energy Q into the water from the surroundings. And so we can use the formula delta E thermal equals W plus Q. And we can rearrange that to get Q equals delta E thermal minus W. And since we're looking for Q, that's what we're going to solve for. And at this point, W equals 100 joules times delta T, because it's force times time. And we already know our delta E thermal, which is 739,200 minus 100 times 15 times 60. And we do the 15 times 60 in order to cancel out the minutes in order to get seconds. As you can see, the M's cancel. And that ends us with a Q thermal transfer of 649,200 joules. This then leads us to the third problem, which is to find the change in delta E surroundings. And delta E system equals negative delta E surroundings. So therefore, because delta E of the system is 739,200, delta E of the surroundings is negative 739,200 joules.